How do I parallelize a simple Python loop? This is probably a trivial question, but how do I parallelize the following loop in Python? I know how to start single threads in Python, but I don't know how to collect the results. Multiple processes would be fine too, whatever is easiest for this case. I'm using currently Linux, but the code should run on Windows and Mac as well. What's the easiest way to parallelize this code?
Using multiple threads on Python won't give you better performance for pure Python code due to the global interpreter lock, GIL. I suggest using the multiprocessing module instead. Note that this won't work in the interactive interpreter. To avoid the usual FUD around the GIL, there wouldn't be any advantage to using threads for this example anyway. You want to use processes here, not threads, because they avoid a whole bunch of problems.
The above works beautifully on my machine, Ubuntu. Package joblib was pre-installed, but can be installed via pip install joblib. Taken from this URL. Edit on Mar 31, 2021, on joblib, multiprocessing, threading and asyncio. Joblib in the above code uses import multiprocessing under the hood, and thus multiple processes, which is typically the best way to run CPU work across cores. Because of the GIL, you can let joblib use multiple threads instead of multiple processes, but this, or using import threading directly, is only beneficial if the threads spend considerable time on I/O, for example read/write to disk, send an HTTP request. For I/O work, the GIL does not block the execution of another thread. Since Python 3.7, as an alternative to threading, you can parallelize work with asyncio, but the same advice applies like for import threading, though in contrast to the latter, only one thread will be used. On the plus side, asyncio has a lot of nice features which are helpful for async programming. Using multiple processes incurs overhead. Think about it, typically, each process needs to initialize/load everything you need to run your calculation. You need to check yourself if the above code snippet improves your wall time. Here is another one, for which I confirmed that joblib produces better results.
To parallelize a simple for loop, joblib brings a lot of value to raw use of multiprocessing. Not only the short syntax, but also things like transparent bunching of iterations when they are very fast, to remove the overhead, or capturing of the traceback of the child process, to have better error reporting. Disclaimer: I am the original author of joblib.
This is the easiest way to do it. You can use asyncio. Documentation can be found here. It is used as a foundation for multiple Python asynchronous frameworks that provide high-performance network and web servers, database connection libraries, distributed task queues, etc. Plus it has both high-level and low-level APIs to accommodate any kind of problem. Now this function will be run in parallel whenever called without putting main program into wait state. You can use it to parallelize for loop as well. When called for a for loop, though loop is sequential but every iteration runs in parallel to the main program as soon as interpreter gets there. One. Firing loop in parallel to main thread without any waiting. This produces following output. Update, May 2022. Although this answers the original question, there are ways where we can wait for loops to finish as requested by upvoted comments. So adding them here as well. Keys to implementations are asyncio.gather and run until complete. Consider the following functions. Two. Run in parallel but wait for finish. This produces following output. Three. Run multiple loops in parallel and wait for finish. This produces following output. Four. Loops running sequentially but iterations of each loop running in parallel to one another. This produces following output. Update, June 2022. This in its current form may not run on some versions of Jupyter Notebook. Reason being Jupyter Notebook utilizing event loop. To make it work on such Jupyter versions, nest_asyncio, which would nest the event loop as evident from the name, is the way to go. Just import and apply it at the top of the cell as. And all the functionality discussed above should be accessible in a notebook environment as well.
If you want to see more display application subscriptions,